get it going. I got a new server set up. Of course. Here we go. Okay. So I thought we could do some scanf here today. That should be fun. And build it into our library. Yeah. So let's go ahead and make ourselves a project. I did switch to ZSH, so that should be, I prefer that. I don't know about you guys, but I seem to like it. So I'm in my main branch. So in the normal directory, if I say 64, so I did have to install again because I have a new server, so the other one was not working. Kept crashing on my Windows PC that it was running on, so that was less than stellar. Now I'm running on an old Linux laptop that I have. That seems to be pretty good. So I'll go ahead and open her up here. So calling scanf. Go ahead and put that over there. And make the font slightly bigger. I don't really want to change my default font because I code during the day, so that's less than fun. So I think the easiest way to figure out scanf is to just call it. So if you call scanf with a format string %d, you have to then give it the address of where you want to save your data. You also have to pound include standard io.h. If you're in C, go ahead and install that, I guess. Make. So if we run this and I type the number 12, it read it in, saved it in that variable. If I printed it, you'd see it. The value is %d, new line, ret status, make, and then run it. If I 23, the value is 23. And so that's the way to call scanf, right? Which is just a function call to be able to read some data from the standard in, and then I'm printing it on standard out. So if we use dump.sh and do our calling, so this function works by saying I want to run object dump on this file, and then if you give it main, it will print off what is inside of main. So here we got scanf on the PLT being called. We can see that they zero out EAX, and then we use RDI and RSI are getting used, right? So RDI should be this one, RSI should be this one. So if we want to call this in our function, okay, so we're going to write a little function here. My scan or read int. Okay. So we basically want to call scanf and then return it. So push RBP, move RSP, move RBP, RSP, move RSP, RBP, pop RBP, capitalize that, ret. Okay. So coming into our function, we're going to return in RAX. So result is in RAX. Okay. So in order to call scanf, we need to move our format into RDI. So if we define our format here, we're also going to have extern scanf. So our scanf format is %d, and then we need a null for our scanf format. And if we want to do this, we need to load into RDI the address of scan format. So as RDI, RSI is going to be a location where we want to store it. So here we could just do sub, allocate it on the space. Sub RSP, let's do 10 hex 0x10. So then we can LEA load the address of RS into RSI of RSP. So that will give us the address. You could just do a move, but I like this because it'll be consistent when we put another variable on there. So RSI needs to have the address of where we're going to, right? So RSI is our second argument. If we look at our scanf, right, our first argument, our format string is in, I gotta scroll better. So that address, so it's doing an LEA and then copying it over. So we're just going to directly load it in there because I know where it's at. And then we're going to call scanf with respect to PLT. Now, scanf should save, so we're just reading a number, so it should be a 32-bit number, so it should fit in a 64-bit register. I'm going to actually move into the value pointed by RSP, and I want to move a D word in there. Or sorry, I want to move a Q word. So 8 bytes keyword. And I'm just going to move 0 in there, because if there's something on there, I just don't want to see it. Like I want to 0 it out. I could just do a D word, but I want to just clear out all the bits in there. And then I did see here it does move 0 into EAX. So let's just do that. Move RX. I'll just do the whole thing. I don't think it's any better or worse to do that. So that should, right, we do a sub of on that, so we need to do an add of RSP 10. And then on our first, like our one farthest down, that's where we're doing the scanf, so the data should be saved in that location. So this is a pointer to where it needs to go. So we don't want to try and get the value because that's not good. But when we return, so I want to return it in RAX, so I want to move into RAX, the value stored at RSP. Right, so I'm going to grab the value and I'm going to put it into RAX so that I can return it. Okay, so I should be able to say call read int and then call dump registers. That is extern registers. Now, let's see. Let's see how good we are. Multiple diffs. So I actually did this beforehand. So let me comment out the one I did in the library already. Let's comment this one out. Or no, we'll just leave it. It's there. Let's just call ours something else. Read int 2. Okay. And I can say global. There we go. All right. Type a number. That was the first scanf. So 12 in hexadecimal, right? So that should be, A is 10, B is 11, C is 12. And the first call was, so I had left this in. I can comment that out. Oh, I want to do a make. Okay, so if I type 16, that's 10 in hex. So that's getting stored here in RAX. And so then we're doing the thing that we wanted to do. So pretty straightforward. I guess, so the one thing that I did want to do, and I did it in my example library, is instead of defining, I've got a whole 2, right? I'm like having to, load this in as a format, but we can figure out what the hex values are for that. So echo let's see, %d, and then put that into xxd just to see it. So that's 2564. So I did subtract 10 here. So I can do move into, I'm just going to do a keyword. Keyword into RSP plus 8, right? So this variable here is taking up 1 slot. So this is going to take up the slot above that. And then I can put, well, I need to reverse my bytes. So 0x6425. And then the rest will be zeros. So it's going to move this value in there. So that's at RSP plus 8. And then instead of me having to say scanf format, I can say RSP plus 0x8. Or 8. It's the same thing. So now it should work the same. If I type 10, get 10 in there. If I type 100, 100 is 64 hex. So you can see that it gets scanned in there. But now I don't have, right? So if I can have this just in the code and not have to do an extra load in order to get it, then it should run tiny bit faster. Not much, but it's less instructions, right? I'm putting it directly on the stack. This is just on the code, putting it in. If you had a big string, right, it probably wouldn't be the best thing to do, but it is something that we can do there. So that allows us to do that, and we can, we can look at our result. Like, we don't have to use dump registers. We can, so if you don't zero out RAX, right? So if in my function, I did zero it out, and I did zero out this location. So if I moved into here 0x, or made -1, right? So that should be all Fs. And I type 12. We can see that the scanf, because I'm doing a 32-bit read, is going to give me 32 bits, which in hex, right? Like that's 8 hex digits. And we see that we still have the 8 hex digits that are just sitting up there, which is why it's nice if you move into a 0 and do it, that it sort of gives you the illusion that there's all of these are zeros. Now you could use a different scanf format. So there are different ones that you can use. So there is one for, let's do a new window. Scanf, long. I always forget what it is. LD. So let's see. Echo. No, let's just do L. Type index 6D. So L is 6C. If I do LD, so it needs to go in the middle. And let's do -1 in there. And here we can move yeah, so it should do what we're looking for. And do what we's looking for. 12. So now it's 12, but it's 64 bits. So it fills that entire thing up. Because I put -1 in here, and if I wouldn't have had a 12, right? If I would take that out, so if this is the last one I move in, I can comment this out or just leave it. But we do that, and we call 12, right? We have Fs, because it's only reading 32 bits. But if instead of doing this one, I do this one, now it's 64 bits. All right, so it allows us to just read more data at once. So I see that I got one viewer on Twitch. So you know, if you have any questions, feel free to ask in the chat. You know, that's how I learn and get better about what I'm doing. Oh. And I don't want to hear myself on stream, so. But. So that seems pretty straightforward, right? Scanf is a fairly simple one. We'll probably look at some more. I mean, the nice thing about scanf is you can kind of see the relationship between the number you typed in and how it converts that into an actual, like it reads the characters and then converts it into the actual data that you want to see there. So that makes it interesting. Okay. So, you know, a more interesting one would be to maybe look at like fopen. So instead of just reading standard in, we could read a file. Right? And we're sort of given a couple things. So if we want to, right, for example, like we could grab, this looks like some pretty standard code. Let's integrate it in. So I already got standard IO. I like to put all my pound includes at the same spot. And there we go. Okay, so we open a file. They're using fprintf, so that's one way to do it. A lot of different ways. And writing it, and so then if I just do a make, and let's look up our dump. Okay. So again, it should be fairly straightforward. So for example, fopen, right? Looks like it only took 2 arguments. So RSI and RDI, it's getting 2 constant values, which are the file and the type of writing permission. When we get to fprintf, it has a variable number of arguments, but I think the sort of there are probably 2 or 3, right? So if you're using the percents, right, you got 3 because you got at least one is the file pointer, one is the format string, and then if there's at least 1 argument, then you'd have an argument in there. So we would typically need 3. You could get away with 2 if it was just a hard-coded string. So we got RDI being the file pointer. So they're taking that pointer from a call to fopen, right? So, or sorry, it's the file pointer. Sorry, RDI gets the value of RAX. RAX is, well, first it's stored and then it's reloaded and then copied into RDI. So that's our file pointer. So you gotta keep track of that. And then our format string should be RSI. So that should, in a PLT or GOT based binary, right, would be, or PIC would be from RIP. So you don't have a hard-coded address. You have whatever it is, whatever offset based on the instruction pointer as opposed to based on anything else. So, but let's see. And then you can, like, instead of using scanf, right, we could use scanf. Now it would allow us to do scanf, but instead of doing it from just the open handle that is, or file pointer that is standard in or standard in, you could read from some other one. So you can do that. I mean, I think it'd be fun to write our own shell that does that. Or another idea I had was doing base64 but using emojis, because why not? I think that would be fun. So we can use this in place of the regular scanf in order to read data. Or we could, in theory, right, use the C++ methods that are built in and be able to read like that. But today is probably going to be a short stream because I got some kids. Gotta go do some mowing for somebody. So we will probably look at this next time. But my server, an old Pop OS laptop seems to be doing okay, even though it's only got 4 cores. I'm not tapping it out. It does have 32 gigs of RAM, so that's nice. But it's got plenty for what it needs to do. Got plenty of hard disk space. Let's see, where is slash? I have 100. That's a lot of assembly files. 167 gigs. Another thing I thought about was, maybe it'd be fun to have a binary that when you run it, it rewrites itself. So if you run it once, it rewrites itself, and then if you run it a second time, it has different behavior, and then you run it again, it goes back to the original behavior. That would be pretty difficult to sort of figure out if all you see it do is it just writes a file, and you're not really paying attention to the fact that it rewrote itself from that. So that seems like that would be an interesting endeavor to go through. I don't think it would be super hard, but it would just be interesting. So if you guys are interested, right, feel free to, send comments. We do have the let's pull up the oh gosh, I did just update this, so we got the template is out there for free, so anybody's able to fork it if you want, and or clone it 100%. So I also did work on doing some Windows stuff, so getting the Windows PowerShell to work, that's probably its own topic. But like the Windows VS Code, I was able to build it into the project, so when it does do a build, see, that's not the one. Oh, is that the one? Read down. I did do a replace. So I don't think it's build. It must be locate tools. Yeah. So yeah, the Windows project. There we go. So I found some code to figure out where VS Code was installed. It goes through this process of installing it, and then you go and get the location of where the tools are installed. So under Windows, there's a couple tools that we end up using. So I end up using CL, which is their compiler, and then as well, we also use the NASM should be installed. So that's kind of, since that's what I'm basing it all on. And then their link. So link.exe allows you to do that. Now, we could also do a project using just NASM, but that does have a slightly different syntax for things like functions and mains. It's not difficult. It is fairly straightforward, but it is different. And some things are defined slightly differently, like keywords that are sort of NASM specific. NASM tried to sort of emulate what MASM did, or the Microsoft assembler, but it also took liberties to make things easier than MASM. And even GAS, which is the GNU assembler, has some additional things like zero terminated strings that are nice compared to even just NASM, off the top of my head. So, but I did get this going. If you guys are interested, we can do some Windows programming. I have plenty of laptops lying around. So, but this goes ahead and redoes that location. So that way, when you build a project using PowerShell, it'll just compile it and run it. Like the whole thing is this quick build. The tool directory gets substituted in using that replace command. And then it just does CL to compile it, and then link it with the different standard libraries that are included, and create your executable using the console and using the object file that gets created with the NASM. I did 64-bit NASM. Again, if anybody's interested in 32, we can always go over it if people in the chat are seem interested in it. Then that's a perfect thing that we can get doing. So, but I think that'll be it for today, guys, and or person, to whoever you are, who's watching, and we'll try and stream again tomorrow. Thanks, guys.